Greeting learners, so we're gonna continue with our session. We have already started with paper one for mathematics exam for last year. So now we're gonna continue with question number 2. Question number 2, given the arithmetic series 7 plus 12 plus 17 plus 211, determine the value of T91. 212, calculate S91. 213, calculate the value of n for which Pn is 517. So we're going to go to the solution for this question 2-1. 2-1-1. Determine the value of T91. So we need first to get the common difference so that it will be easy to get T91. So 7 plus 12 plus 17, the common difference here we can see D is equal to 5. 12 plus 5, we get 17. 17 plus 5, then we're going to get 22. Now, the formula for the general term Tn is equal to A plus n minus 1 times D. So our Tn will be equal to A. The first term is 7 plus n minus 1 times 5, 5 being the common difference. So Tn will be equal to 7 plus 5n minus 5, and Tn will be equal to 5n plus 2. This is the general term. So if we want to get T91, we're going to replace n by 91 plus 2, 5 times 91 plus 2. Using our calculator, we'll be getting 5 times 91 plus 2, and the answer is 457. So T91 is 457. This is question 211. We're going to take question 212, the next one. 212. Here they want us to get the sum of the first 90 first terms. We know the formula for the sum as n is equal to n over 2, a plus l. A being the first term and l being the last term, like Tn. So S91 will be equal to 91 over 2 times A is 7 plus T91, we got it already, is 457. S91 will be equal, we also going to use our calculator, 91 multiplied by 7 plus 457 over 2. And then we get 21,112. That is the sum S91. That was question 212. Now we're going to take the next question is 213. Calculate the value of n for which Tn is equal to 517. So here we will be having our general term here is 5n plus 2, and this will be equal to 517. Thus 5n will be equal to 517 minus 2. 5n will be equal to 515. So n will be 515 over 5. And n will be 515 divided by 5. We get 103. So here it will be 103. Responding to our question, so we will write T103 will be equal to 517. So we are done with this first question 2-1. We're gonna clean the board and then we'll go to the next question. Okay, so we're taking the next question is 2-2. The following information is given about a quadratic number pattern. T1 is equal to 3, T2 minus T1 is equal to 9, and T3 minus T2 is equal to 21. 2 to 1 show that T5 is equal to 111. Triple 2 show that the general term of the quadratic pattern is Tn is equal to 6n squared minus 9n plus 6. And 2 to 3 show that the pattern is increasing for all the n being natural numbers. So we're going to the solution. 2 2 2 2 1. The first term T3, we know that is a quadratic number pattern. Remember, quadratic number pattern, the general form is Tn is equal to an squared plus bn plus c. So here, our Tn is given, so we're having 3 here, and T2 minus T1 is going to be 9, meaning we're going to have 9 here. 9 plus 3, we're getting 12. Because 12 minus 3, we're going to get 9. And then T3 minus T1 is equal to 21. So meaning here, we're going to get to 21 T3, we will get a number here minus this one, we get 21. So it's going to be we're going to get a number here. This number minus 12, we're going to get 21. What will be that number? That number is going to be 21 down here, 12 plus 21, then we are getting 83 because T3 minus T2 will get 21. As you can see here already, the second common difference down here will be 21 minus 9 is going to be 12. And then we will continue here to get the next one. The next one will be 21 plus 33. Here, 3 plus 9, we're getting 12. 12 plus 21, we're getting 33. So as we are having here, the second difference is going to be 12. We will need to get a number here so that here the difference will be 12. So it will be 21 plus 12. Then we're getting 33 will be the next first difference. 33 plus 33, we're getting 66. And here, we're still going to have the second common difference, 12. 33 plus 12, here we're getting 45. And 66 plus 45, then we're going to get 111. As you can see here, we were supposed to show that T5 is equal to 111. As you can see here, 1, 2, 3, 4, 5, T5 is equal to 111. We can also do this taking our calculator, 3 plus 9 plus 21 plus 33 plus 45, we will get 111. Let's check this. 3 plus 9 plus 21 plus 33 plus 45, then we're getting 11. 111. So I'm going to also write this so that we can see that T5 will be equal to 3 plus 9 plus 21 plus 33 plus 45. Then we're getting that T5 is equal to 111. So this was practically question 221. We are going to go to the next question. We're going to go to the next question. 222. 222. Show that the general term of the quadratic pattern is Pn is equal to 6n squared minus 9 plus 6. So we know that Pn is equal to an squared plus bn plus c. We need to get the value of a, b, c, and then we will show that our Tn is 6n squared minus 10 plus 6. We know already that our first term is 3, T2 is 12, and the next one is 33. For quadratic number pattern, we'll remember that if we are having our second common difference, 2a will be equal to 12. This is our second common difference. With this, we're getting the value of a. We can see that the value of a is 6, as we can see here. Now, coming back to this, we're going to replace n by 1. T1 will be equal to a plus b plus c, and T1 is 3. And we know that T2 is 12. As we can see our chain here, we're going to write here T2 is equal to, we replace n by 2, we will be having 4a plus 2b plus c, and this will be equal to 12. So we're going to replace a by 6 here. So 6 plus b plus c is equal to 3. And here 6 times 4, we're going to get 24 plus 2b plus c is equal to 12. So I'm going to clean the board here just to finish up this question. I'm just going to clean this first part here because we have already responded to question 221. We want to finish up with this. Okay, so we're practically having a simultaneous equation here where we need to get b and c. So b plus c will be equal to 3 minus 6, then we get minus 3. And here 2b plus c will be equal to 12 minus 24, then we're getting negative 12. So we're going to take this second equation minus the first one, 2b minus b, then we're getting b. B will be c minus c, 0, minus 12 minus 3 is going to be minus 12 plus 3. So our b is a negative 9. We're having a is equal to 6 and b is equal to negative 9, as you can see here. Now we will use T1 to get the value of C. A 6 plus B negative 9 plus C is equal to 3. This will imply that negative 3 plus C is equal to 3, and C will be 3 plus 3, then we get 6. So we're having A 6, B negative 9, and C is equal to 6. Finally, our general term will be a 6 n squared, then our b is negative 9n plus c 6. We have shown that the general term if this quadratic pattern is Tn is equal to 6n squared minus 9 plus 6. So we're done with question 2.2. We're going to go to the next question 2.3. I'll clean the board, then we're going to have some space to finish up with this question. Okay, let's finish up with the question 2.3. Show that the pattern is increasing for all natural numbers. So n is a member of n. So to show that, we're going to take here the first derivative of this quadratic form here. We will be having t prime n will be equal to 12n minus 9, and this will be positive for showing that this pattern is increasing, considering n to be a natural number. So we'll be having 12n minus 9 is greater than 0. We're going to divide by 3 here. We'll be having 4n minus 3 is greater than 0. 4n will be greater than 3. And finally, n will be greater than 3 over 4. So we're going to conclude that Pn is increasing for all n being a member of natural number. So it will be for n greater than 3 over 4. I think we're done with question number 2. We'll clean the board and go to the next question, and that will be question 3. We're done with question 2. Now we're going to take question 3. Given the geometric series 3 plus 6 plus 12 plus dot dot 2 n terms 311, write down the general term of this series. 312, calculate the value of k such that the sum p from 1 to k of 3 over 2 times 2 to the power p is equal to 98,301. So we're having a geometric series. The first question, they want us to get the general term of this series. So we're going to the solution. As we can see, our geometric series, in terms of sequence, we'll be having the first term is going to be 3, the second 6, the third one will be 12. So we're writing A is equal to 3, and our common ratio will be equal to 2. 3 times 2, we get 6, 6 times 2, we get 12. So the general term Tn will be equal to, as you can remember for a geometric sequence, Tn is a times r to the power of n minus 1. So here our a is 3, will be times 2 to the power of n minus 1. This is the general term of this series. Now going to the next question. 312, to calculate the value of k such that the sum from p starting from 1 to k of this general term 3 over 2 times 2 to the power of p is equal to 98,301. So here, if you can remember, the formula for the sum for a geometric series is Sn is equal to a times r to the power of n minus 1 over r minus 1. So here, our p is starting from 1 and the last one will be k. So p is equal to k. We will write here Sk will be equal to A times r to the power of k minus 1 over r minus 1. Our A, as you can see, is 3. And then we're going to have here a common ratio is 2 to the power of k. We're dealing with k here, minus 1 over 2 minus 1. And this will be equal to 98,301. So we're going to get here 3 times 2 to the power of k minus 1. This will be equal to 98,301 because the denominator is 2 minus 1. 2 minus 1 is equal to 1. So in order for us to get the value of k, we're going to divide both sides by 3. So we'll be having 98,301 divided by 3. We're getting this number. So we're going to get here by 3 by 3. 2 to the power of k minus 1 will be equal to 32,767. And solving for k, 2 to the power of k will be equal to 32,767 plus 1. Then we get here minus 1 will come this side, plus 1. It's going to be 32,768. Let's see if this number can be a power of 2. 2 to the power of 2 to the power 15. Alright. So here we're getting that 2 to the power of k will be equal to 2 to the power of 15. 2 to the power of 15 is equal to 32,768. So definitely the value of k will be equal to 15. Then we are done. The value of k here we're looking for is 15. We are going to continue the next question here. Here is 312. We are done with this first question. Let's clean the board and write the next question. This is the following question on question number 332. A geometric sequence and arithmetic sequence have the same first term. The common ratio of the geometric sequence is 1 over 3, and the common difference of the arithmetic sequence is 3. The sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. Calculate the value of the first term. So they are saying here that a geometric sequence and an arithmetic sequence have the same first term. This is practically the question they're asking us to get the value of the first term. But here are the information we have in. The common ratio of the geometric sequence, here, and here is the arithmetic sequence. For the geometric sequence, the common ratio r is equal to 1 over 3, and the common difference for the arithmetic sequence is 3. D is equal to 3. Now, this is the information we are having. R is equal to 1 over 3, and D is equal to 3. And this is the next point here. The sum of 22 terms of the arithmetic sequence is 734 more than the sum to infinity of the geometric sequence. What are we going to have here? Sum of 22 terms of the arithmetic. So we'll be having the S22 is going to be equal to the sum to infinity of the geometric sequence, and that is 734 more. So it's going to be plus 734. So this is practically all the information we are having. First point, common ratio 1/3, common difference 3, and this last information, S22 is equal to S to infinity plus 734. With all of this information, we need to get the value of the first term. So this is what we're going to do. I can also add here like A is equal to A. The first term of these two are the same. So A is equal to A for both of them. So here I'm going to get the sum of the 22 terms. Then we know that Sn is equal to An over 2 is N over 2 A plus L. So we're going to replace here S22 will be equal to 22 over 2 and A plus L. Now, for the arithmetic sequence, remember Tn is equal to A plus n minus 1 times D. Our Tn here will be equal to A. N is 22. So we'll be calculating here T22. T22 will be equal to A. 22 minus 1, we're getting 21. And our common difference is 3. Here we're going to multiply by 3. So T22 will be equal to A plus 63. 21 times 3, we get 63. So I'm going to clean the board here to have some space for that we can continue with this question. We have already used all of this information, all of them, so we're now continuing in order for us to get the value of A. Okay, S22 will be equal to 22 divided by 2, we're getting 11, and the A plus T22, this will be practically our L here, so it will be A plus 63. Then we're getting 11, 2A plus 63, we'll be getting 22A plus 63 times 11, what are we getting here? 63 times 11, then we get 693. Now, we're going to equate this as we are having this here, but we're also going to need to get the sum to infinity. The sum to infinity is A over 1 minus R. Sum to infinity for the geometric sequence will be A. We don't know the value of A. This is practically what we are looking for. And the common ratio is 1/3. Here at the denominator will be having 2/3. So S to infinity it will be 3/2A. That is our sum to infinity. Now, we're going to replace here. Sum to infinity is this. Yeah. So we have already used this information. Let's continue now. We're looking for the value of A. So we'll be having this 22A plus 693 will be equal to this sum to infinity 3/2A plus 734. So we'll be getting a common denominator here. We multiply here, we're gonna be having 44a plus 693 times 2. 693 times 2. Here we're getting 1386. This will be equal to 3a plus and 734 times 2, we're getting 1468. Now, here we're having a as the unknown value we're looking for. 44a minus 3a is going to be 41a is equal to 1468 minus 1386. How much are we getting there? Minus 1386, 1468 minus 1386. Then we are getting 82. So here we'll be having 41a is equal to 82, and the value of a will be 82 over 41. A is equal to 2. So the first term of this sequences will be a for the geometric sequence and 2 for the arithmetic sequence. Then we are done with question 3. We finish with question number 3. We're gonna clean the board and go to the next question. Question number 4 now.